Here we go with our video for the AP Calculus AB Unit 3 Progress Check Solutions. I think it's good to do the video so we can get some more in-depth explanations along with the solutions as opposed to just seeing the solutions on paper. So looking at what we have on this first one here. So we want to know what is the derivative of our f of g of x. And with this compound, this composite function that is, we know that's going to be, we're going to have f prime of g of x times g prime of x. And in this case, we know g of x is natural log of x. So looking at, let's go ahead and rewrite this. So we're looking at the derivative of f of natural log of x. So that's going to get, well, we don't know what f is, but we know we've got f prime log of x, just going off what we have up here, times, and now g prime of x, we know it's going to be 1 divided by x. And putting that all together, that gives us f prime natural log x divided by x. So we're talking about d. All right, number 2, what do we got going on here? Using our chain rule. Let's look at the fact that 1, well, that's a composite function right there. So we want the chain rule with that one. 2, that is a product there. So we're not going to use 2. So we know that's out. And we know that one is out because we've already established that 1 needs the chain rule. So is it A or is it D? Well, if we look at our third one, we could use the quotient rule, but we could also, if we write this, if we look at it that way, then we're looking at using the chain rule, and it actually would be easier to do that. So now we're looking at D, 1 and 3. Now we have a case, all right, what's going on with this one here? We've got f as a differentiable function and h, all right, so we want to use this information, tells us that we can differentiate this right here. So looking at what we've got our sum and product rules with our derivatives, but also this creates a composite right here. That creates a chain rule situation. So that h prime of x is going to equal, now I'm going to have 2 times 1 plus f of 3x. So that's our outer function. X raised to the 1 power. If we look at that, we can think of this as h of x equals u squared, and u equaling 1 plus f of 3x. That's what we're looking at here. All right, so now, again, with our chain rule situation, then we've got to look at, now we're dealing with f of 3 of x. So we have a chain rule situation within a chain rule situation. So taking the derivative of that right there, we're looking at f prime. We don't know what f is, but that doesn't matter. So we're looking at f prime 3 of x, kind of like with our first one. And then we got to multiply by our most interior portion, so that's times 3. And we could, well, putting that all together, and again, we see that is answer choice D. All right, let's keep it moving here. Number 4. There we go. All right, we want to know the slope of the tangent line. What does that mean? So we know the slope of the tangent line. We're looking at taking the derivative. All right, now we got a little bit of work to do with this one. Because we cannot write this explicitly as a function of x. So we're going to have to use implicit differentiation. All right, so we know that's going to be 3y squared. And I'm going to use Leibniz notation, 3y squared. For the ease, I like to put y prime, but I think when we write dy dx, that helps it stand out more. So minus, now we've got a product rule situation here. So we have f prime, f is x, g is y squared. So f prime is 1 times g gives us y squared plus f times g prime. So that gives us 2xy. Then we've still got our dy dx. And we can differentiate this straight up, 3x squared. And that equals 0. Derivative of that constant is 0. Now let's go ahead and actually, we got to be careful here. Put that in parentheses because we're saying minus taking all this derivative right here. So now that is going to give us 3y squared dy dx minus y squared minus 2xy dy dx plus 3x squared equaling 0. Now let's group some stuff together and move some things around. We can factor out dy dx, and then we have 3y squared minus 2xy, and that equals y squared minus 3x squared. So now that gives us dy dx equals, make my equal sign look a little better, y minus 3x squared divided by, what's that, 3y squared minus 2xy. So that's dy dx. We want to know dy dx at that point. So dy dx at our point 1, 2 is going to equal, that is, y squared. There we go. That is 2 squared minus 3 times 1 squared divided by 3 times 2 squared minus 2 times 1 times 2. And this is not free response. We've got to go ahead, work that all the way through to see which one of our choices that matches. So we have 4 minus 3 divided by 12 minus 4, and that equals 1/8. And we can see that is answer choice B. All right, so now moving along. Number 5. Ooh, number 5 is a good one. All right, so I want to try a thinner marker this time. So we see we've got implicit differentiation going on. So our dy dx, if we differentiate our left side, so we're looking at cosine x plus y because derivative of sine is cosine, but then we got to multiply times, and then we got our, what's this, sum and product rule. So the derivative of x is 1, and the derivative of y is 1 times dy dx. And that equals 3 minus 2. And the derivative of that y is dy dx. All right, now over here we've got to use our distributive property. Well, we don't got to. There's a couple different ways we could do this, but I want to go ahead use my distributive property. So I have cosine x plus y plus cosine x plus y dy dx, and that equals 3 minus 2 dy dx. Now let's do some moving things around, shifting. That'll give us cosine x plus y dy dx plus 2 dy dx equals 3 minus cosine x plus y. And now we can see over here, we can factor out that dy dx, get it by itself eventually. Dy dx, we have cosine x plus y plus 2, and that equals 3 minus cosine x plus y. And because this is a multiple choice, I can see what my answer is going to be. So I'm going to write it dy dx equals 3 minus cosine x plus y. And as my denominator, I'm going to go ahead and switch that around and say we have, using our commutative property of addition, 2 plus cosine x plus y. And we can see that is what answer choice D. And for the sake of it, I haven't been boxing my answers. All right, go ahead, box that. All right, number 6. What's going on here with number 6? Okay, I'm not going to read that, but I'm just going to hop right into solving this here. We want to know dy dx at that point, but we have this part right here. So what we're going to have to do is say that, I'm going to go ahead and rewrite that. F of x g of y equals 17 minus x minus y. So we have to be able to do this abstract type manipulation here. So we're looking at f prime g. So f prime of x g of y, because we got our product rule, plus fg prime. So fg prime is going to be f of x g prime of y dy dx. And that's going to equal, again, derivative of a constant is 0. So we've got minus or negative derivative of that x is 1. And then we got minus derivative of that y is dy dx. Now at this point, I want to go ahead and start doing some substitution. So f prime, we're looking at the point negative 2, 4. All right, so f prime of negative 2, we see f prime, f prime of negative 2 is 4. G of y, g of 4 is 5. Plus f of negative 2 is 3. G prime of 4 is 2. And that's still multiplied by dy dx. And that equals negative 1 minus dy dx. So we have 20 plus 6 dy dx plus dy dx equals negative 1. So that gives us 7, all right, 6 dy dx plus dy dx. We have 7 dy dx equals negative 1 minus 20, negative 21. So that dy dx equals negative 3. Answer choice C. All right, this one here. Now, I don't know if there's any way I can shrink this. I'm not going to mess with it. All right, what are we looking at here? We've got decreasing function, line tangent at 4, 6. Okay, this is true. All right, so we're looking at G prime. That's what I was looking for. Okay, G is the inverse of F. I knew I had some important information. All right. Now, so we're talking about a statement of G prime, or G prime of 4 or G prime of 6. Let's look at the fact that since we have G equals the inverse of X, and actually I want to bring in this right here. Come on. There. I know that since G is equal to the inverse of F, that means G prime of X equals F prime G of X, that reciprocal. And let's see here. We know that G of 6 equals 4. All right, since we know F of 4 equals 6, therefore G of 6 equals 4, since they are inverses. All right, keeping that in mind. And now, okay, so since G of 6 equals 4, and we want, we're looking at G prime of 6 is what we're looking at here. So G prime of 6 is going to be F prime G of 6. So that's going to equal 1 divided by F prime, and G of 6 is 4, as we saw. So what is F prime at 4? Well, it tells us that this is our tangent line, and it's tangent at the point 4, 6. So we're looking for what is the slope at 4, 6. So our slope we see our slope there. We have a rise of -3 and a run of 4. So our slope is -3/4. So our G prime of 6 is going to equal 1 divided by -3/4, which equals -4/3. And what answer choice was that? Let's guess it doesn't really matter, but just to know for sure, C. Want G prime of 6. And as we look at our answer choices, again, it's very important when we put together all the information that we were given, the fact that G and F are inverses, and we know that F of 4 is 6, so G of 6 equals 4. That is what we're going off right there. All right, number 8. What's going on with number 8? Kind of the same thing, and it got cut off there. All right, so we're looking for G prime of 2. G is the inverse, so we know G prime of 2 is going to equal 1 divided by F prime G of 2. All right, starting to go slanted here. See if we can straighten this out. Now, how do I want to approach this? Let's go ahead and say that we know that F prime of X is going to equal 3x squared plus 4x plus 4. And we know F of -1 equals 2. So because F of -1 equals 2, we know that G of 2 is going to equal -1. So G prime of 2, let's go ahead, got room. G prime of 2 is going to equal prime negative 1. The reciprocal of f prime of negative 1. Well, what's f prime of negative 1? F prime negative 1, we've got 3 times negative 1 squared plus 4 times negative 1 plus 4. Oh, wait a minute. Going too far. Here's our answer right here. G prime of 2 equals 1 divided by f prime of negative 1. So that is answer choice B. All right, number 9. We've hit our halfway point here. I got cut off again. Let's see, G prime of 2. So once again, we've got G prime of 2, knowing that G and F are inverses. It's going to be F prime G of 2, the reciprocal of that. And let's see, what do we have here? G prime of 2. So in order to find G of 2, we want to use the fact that F of 4 equals 2. Therefore, since they're inverses, G of 2 equals 4. And let's see, we need, so F prime of G of 2 is F prime of 4, which equals negative 5. So this is equal to 1 divided by negative 5, which is negative 1/5. Box it and point out, let's see, it's this one right here. Okay. Numero 10. This is one, you got to memorize this one right here. Derivative of our inverse sine is 1 minus x squared, that square root, and the reciprocal of that. And all we're doing here is substituting 1/2 in for x. I don't know why I'm going so slanted here. 1 minus 1/2 squared, that, and there. So we're looking at B. Number 11, that's also a memorization, and that is negative 1 minus x squared, that reciprocal. All right, number 12. This one, let's see here. We've got, well, I just want to point out, first of all, that 1 over, we know arc sine x equals inverse sine x, but does not equal 1 over sine x. So we can rule out this one right here. And this one is kind of difficult to show it on the video, but I'll just say, going off how we did in class, this was one way we can do it. Sine of the arc sine of x equals x, or using the fact that sine y equals x. When we're looking at inverse, if we have y equals inverse sine of x, that means the sine of y equals x. So it comes down to, it's 2 and 3. All right, 13. 13, this one, that's a composite. It's a composite right there. This is some product. No, some difference. think I said sum product earlier on something else. Sum and difference. This one is also, D is also a composite. So that one right there is our product rule. All right, this one right here, implicit differentiation. This one only has one y. We can write that explicitly, y as a function of x. X is a function of y. Same thing over here. We have y by itself. We have x and x. That can be written explicitly. We have y over here. We have x and x. That can be written explicitly. But here we have y and y, so that one requires implicit differentiation. All right, this one, quotient rule. All right, this is a composite, so we could use our chain rule here. This one could also be chain. It could be quotient, but it could also be chain. And we're talking about quotient rule will be considered the best method. So the best method for that one probably is not quotient, because we can write, that could be argued. This one right here, that's also chain. So it is D. That one right there, quotient rule would be the best way to go about that one. All right, number 16. Oh, we're looking at a fourth derivative here. So let's go ahead and get to it. So y equals 2 natural log x, giving us dy dx is going to equal 2 divided by x, all right? Or 2x to the negative 1. So that d squared y dx squared is going to equal negative 2x to the negative 2. All right, so we can just go on with our power rule now. D cubed y, get a little neater here, dx cubed is going to equal, so that gives us 4x to the negative 3. And then we're going for a d fourth y, dx to the fourth is going to equal negative 12x to the negative 4, which equals negative 12 divided by x to the fourth power. And we see that is answer choice B. All right, 17, we're looking for, all right, so this tells us we have the graph of f prime, all right, okay. And we know if we have the graph of f, the derivative are the slopes at points along the curve. So if we have f prime, the graph of the derivative, and we're looking for the second derivative, well, we're looking for the slopes at points along the curve. Still, same principle applies. As we look at this, and we can look at that slope right there, okay, and we're definitely steeper right here. This looks like a horizontal, and this is steeper. This is actually D is the steepest slope, but at B we're positive. This is negative. Positive is always going to be greater than negative, so our answer is B. The value of our second derivative is greatest at B because that's where our slope is the greatest. All right, and last but not least, number 18. That's what we got going on. All right, so twice is a y equals f of x is a twice differentiable function. That is important to know because we're asking for the value of the second derivative. So if it were not twice differentiable, then this would not matter. Okay, so let's go ahead and get into this. So we need to take the derivative of our derivative. So that means d squared y dx squared is going to equal, and the derivative of this, we're going to have 2 y squared plus 7x squared 4. All right, so taking the derivative of this portion right here, of course, that's how we get this. And then we have our constant out front, and that is going to be multiplied by the derivative of our radicand. So that is going to give us 2y dy dx plus 14x. Let's make that look a little better. There, plus 14x. All right. And it's also important to note that since we're looking for the value at x equals 1, it's also important to know that f of 1 equals 3. So now what I want to go ahead and do and say that we want dy dx at the point 1, 3. Because we're looking for it when x equals 1, and when x equals 1, y equals 3. All right, so we got to put together all of that information here. And so that is going to equal, let's see, we've got, okay, 4 square root of 3 squared plus 7 times 1 squared, which is going to equal 4, all right, do it all the way, not going to skip any steps, 9 plus 7, that equals 4 times the square root of 16, which equals 4 times 4, and that equals 16. And now we can go ahead with this expression right here for d squared y dx squared. That is going to equal, and I'm going to go ahead and simplify that. 4 halves is 2. Divided by, now I already know that this is the square root of 16. I'll just go ahead and put it as the square root of 16. And that's going to be times 2, y is 3. And we've already calculated that dy dx at the point y3 is 16. Plus, and we have 14 times 1. So that's going to equal 2 divided by square root of 16, 2/4. Go ahead, simplify that to 1/2 times 2 times 3 times 16 is 96 plus 14. So we're looking at 1/2 of 110. And that equals 55. All right, that was a fun little problem right there. Okay, and that is it. That's our video for our Unit 3 progress check, multiple choice questions.